Welcome to Creata classes. The topic of the lecture is the distance of a point from a line. In this lecture, we will see how to calculate the distance between a given point and a given line. Before that, let's see what is the distance between a line and point. As I have already told in the basic geometry chapter, the distance between a line and a point is the perpendicular distance. If we take a line and a point, there can be several distances between a point and a line. All these can be the distance between the point and a line, okay? But we will take this perpendicular distance as a actual distance between a point and a line. Got the point? Only the perpendicular distance will be considered as a distance between the point and the line. So in this lecture, we will see the formula of a distance between a point and a line. Let's proceed with the lecture. Let's take a line L, that is ax plus by plus c equal to 0. And let's take a random point P with the coordinate as x1, y1. And we have to calculate the distance between this point P and the line L. So let's take a perpendicular distance, that is this distance PM. Okay. We will denote the PM as small d. So this d is the perpendicular distance between the point and the line. And in this lecture, we will see the formula of the d, that is the distance between the point and the line. Okay. So let's proceed. Our equation of the line is ax plus by plus c equal to 0. Can we rewrite this equation into the intercept form? That is x by a plus y by b equal to 1. The same we have covered in the previous lecture. So we can rewrite our general equation into the intercept form. We got our x-intercept, that is small a, as minus c by a, and the y-intercept as minus c by b. Okay, we got our x-intercept and y-intercept of this line L. What we have done, we have simply converted our general equation of the line into the intercept form. Further, we got our x-intercept as minus c by a, means this distance will be x-intercept, okay? And y-intercept, that is minus c by b, will be this distance. Let's denote this point as point Q and this point as point R. That is, Q is the x-intercept and R is the y-intercept. Further, can we write the coordinate of point Q as minus c by a, 0, and the coordinate of point R as 0, minus c by b? Okay, we can do so, as our x-intercept is minus c by a and our y-intercept is minus c by b. Moving further, are you able to observe this triangle inside this figure? This is a triangle with the vertex as P, Q and R. And we know the coordinate of all the three vertex of this triangle. We also know the formula of area of the triangle is equal to half into base into height. Here RQ will be the base of this triangle and PM will be the height of this triangle. PM, that is the distance d, whose formula we have to calculate. So we got area of the triangle equal to half into RQ into d. So we got d equal to twice of area of triangle PQR upon QR. So basically, if somehow we got the area of this triangle PQR and the distance QR, then we can got the value of d, that is the distance between the point and the line. So can we calculate the area of this triangle and the distance between Q and R? Can we? Let's see. Firstly, let's check the area of the triangle. The coordinate of the three vertex of the triangle are given. So can we apply the formula of our area of the triangle? The formula of area of the triangle that we have seen in the previous lectures is half into mod of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, this is the formula that we have covered in the previous lecture. Let's take our point P as x1, y1, that is already given as x1, y1, and point Q as x2, y2 and point R as x3, y3. Let's put the value. On putting the value and solving, we got area of the triangle as half times mod of x1 into c by b plus y1 into c by a plus c square upon ab. Okay, we got the area of the triangle. Now let's move further and let's calculate the distance QR. We know the coordinate of point Q and the coordinate of point R. Can we calculate the distance between point Q and R using our distance formula? Okay, the same we have covered in the previous lecture. The distance formula, that is the distance between any two given point, is root of x2 minus x1 whole square plus y2 minus y1 whole square. Here we know the point Q and point R. Let's put the value and let's solve it. We got QR equal to mod of C upon AB root of A square plus B square. Okay, we have put the term C upon AB in the mod because it may be positive or it may be negative. Basically, we are doing so that C upon AB can be cancelled out with the area of the triangle. Okay, let's see what I am talking about. Further, we got the area of the triangle and the distance QR. Let's find the value of D. Let's put the value. On putting the value and solving, we got D, that is the distance between the point and the line, as mod of AX1 plus BY1 plus C upon root of A square plus B square. This is the perpendicular distance between the line AX plus BY plus C equal to 0 from a point X1, Y1. Okay, this is the formula of the distance between the line and the point. Got it? Moving further, now we will calculate the distance between the two parallel lines. Okay, we will calculate the distance between the two parallel lines. This concept will be similar to the distance between a line and a point. So we have covered under this topic. Okay. Let's assume a line with equation as y equal to mx plus c1. Here m is the slope of this line and c1 is the y-intercept. The same equation we have already covered in the previous lecture. Further, let's also take another parallel line, that is y equal to mx plus c2. These two lines are parallel to each other, so their slope will be equal. Only the difference between both of these equations will be c1 and c2. C1 will be the y-intercept of the first line and C2 will be the y-intercept of the second line. And all the other parameters will be same as both the lines are parallel to each other. And we have to calculate the distance between both of these lines, that is the perpendicular distance between both of these lines. Let's assume the perpendicular distance as d. If somehow we are able to find any point on the first line, then we can apply our previous formula and find the distance between the point and the line. Okay, got it? Moving further, can we find the x-intercept of our first line? Let's denote the point A as the x-intercept of first line. At the x-intercept, the y will be 0. So let's put y as 0. We got x as minus c1 by m. That is the coordinate of point A as minus c1 by m, comma 0. Okay, what we have done? We have find the x-intercept. X-intercept is a point where the line is crossing the x-axis. That is where the y-coordinate is 0. Okay, at the point A, that is at the x-intercept, our y will be 0. So we have put the value of y as 0 in the equation. So we got x as minus c1 by m. Okay, got it? So we got the point A. So now can we find the distance between the point A and our second line? Okay, let's see. Here can we rewrite our second equation as minus mx plus y minus c2 equal to 0. That is, if we compare this with our general equation, that is ax plus by plus c equal to 0, can we say a equal to minus m, b equal to plus 1 and c is equal to minus c2. We got a, b and c, and x1, y1 are minus c1 by m and 0. Okay, let's put the value in our formula. On solving, we got the distance d as mod of c1 minus c2 upon root of 1 plus m square. Okay, got it? This is the formula distance between two parallel lines. Okay, so basically in this lecture we have covered two formula. The first formula we have seen the distance between a point and a line, and the second formula we have seen the distance between two parallel lines. Point to be noted here is that we have calculated the distance between two parallel lines. Don't be confused with any line. This formula is applicable only and only when the two lines are parallel to each other. Okay, when the two lines are parallel, their slope will be equal. That's why we have taken slope of both of this line as m. Got it? Let's take a question. The question is, find the distance of a point 3, minus 5 from the line 3x minus 4y minus 26 equal to 0. In this question, the coordinate of the point P is given as 3, minus 5, that is x1, y1 is given, and the equation of the line is given as 3x minus 4y minus 26 equal to 0. So we can say A is given as 3, B is given as minus 4, and C is given as minus 26. Now we can apply the formula of the distance between a point and the line, that is D equal to mod of AX1 plus BY1 plus C upon root of A square plus B square. Let's put the value and let's solve it. We got the distance as 3 by 5. That is the answer of the question. Got it? Let's take one more question. Find the distance between the parallel line 3x minus 4y plus 7 equal to 0 and 3x minus 4y plus 5 equal to 0. In this question, we have to find the distance between two parallel lines. And we know the formula of the distance between any two parallel line is D is equal to mod of C1 minus C2 upon root of 1 plus m square. So basically we will need the slope of these parallel lines and we need the y-intercept of both of this line. Okay, let's see. Here let's convert both of this equation to the y-intercept form, that is y equal to mx plus c. We got our first equation as y equal to 3 by 4x plus 7 by 4. That is the small m, that is slope of this line is 3 by 4 and the y-intercept is 7 by 4. That is c1 is 7 by 4 and m is 3 by 4. Let's also convert our second line to the slope intercept form. We got y equal to 3 by 4x plus 5 by 4. That is we got slope as 3 by 4. Both of these lines are parallel, so their slopes will be equal to each other. And we got y-intercept of second line as 5 by 4. Okay, we got m, c1 and c2. Let's put the value into the formula and let's solve it. We got D is equal to 2 by 5. That is the answer of this question. Okay. So that's it for this lecture. Thank you very much for being with Creata classes. Bye for now.